so now I will be discussing about the KMM 2022-2023 SMART CHEM. Okay, so now let's have a look at the question. Okay, so now neon consists of three isotopes, 20 Ne, 21 Ne, and 22 Ne, with the percentage of abundance 91%, 0.1%, and 8.9% respectively. Calculate the relative atomic mass of neon. Okay, to find the relative atomic mass, we have to know that we have to find average atomic mass first. Average atomic mass. Then only that we convert it into relative atomic mass. But how do we actually find the average atomic mass? So we have to apply this formula, KMPK, short form KMPK lah. Okay, so K is actually the percentage abundance, which is these three, the percentage, and then me is actually the masses, which is indicated here, 20, 21, and 22. Okay, so now by applying this formula, we substitute all the values provided in the question. So 91% is actually for 20 Ne. So 91 times 20 plus 0.1% times 21 Ne plus 8.9% times 22 over 91 plus 0.1 plus 8.9, and this is actually equals to 100%. But I write it out so to clearly state out all the key actually indicate. So after the calculation, we can find the average atomic mass, which is equals to 20.18 AMU. Okay, so please note that we have to write the unit AMU, which is actually the average mass unit. Sorry, is actually atomic mass unit. Yeah, and then we have to know that the decimal places should actually 2 decimal places only for the final answer. And then after that, to find the relative atomic mass of neon, we can simply divide it by 1/12 times 12 AMU, which is actually 1/12 times carbon 12. Okay, then after that we divide, and then we will find this answer, 20.18 without the unit. The relative atomic mass have no unit, please note that. Okay, so now for this next question, B, a 30.00 ml solution containing Fe2 plus ion titrated with 50 ml of 0.1 m potassium dichromate K2Cr2O7 solution in acidic medium form Fe3 plus and Cr3 plus ions. Okay, so for the first Roman, it wants us to write the balanced ionic equation for the reaction occurred above. And then second Roman, calculate the concentration of Fe2 plus ion. Okay, so let's discuss for the first Roman first. Okay, so 1B1. To write the balanced ionic equation, we have to divide the equation into 2 parts. One is oxidation and one is reduction. Okay, so for oxidation, it's actually at first is Fe2 plus, and it is aqueous because it is inside the solution already, and then we have Fe3 plus ion. Fe2 plus becomes Fe3 plus, and then we have to balance it, so we have to add 1 E here because here is 2 plus, here is 3 plus. So in order to balance it, here must minus 1 in order to become 2 plus. So we add 1 E. Okay, so for the next is the reduction, and from the question it's actually K2Cr2O7. But after we dissociate or we dissolve inside the solution, the water, and it will dissociate into K plus, and then K plus ion, and then also Cr2O72 minus ion. Okay, so but we just take this for the reduction. Okay, so reduction. So initially we have this Cr2O72 minus aqueous, and then becomes Cr3 plus. The question here already stated forms Cr3 plus. So we have to balance it. So first we have to balance the atom beside from O and also H. So we first balance the Cr. Here got 2, right? So here need to add 2. And then after that we have to balance the O. Here got 7. So here we need to add 7 H2O, but not O. Please remind that. Please be remembered about that. Yeah, so this one also need aqueous, this one is liquid. And then we have another thing, which is to balance the H plus, because here got 14H. So here we need to add 14H plus aqueous. And then after that, finally we have to balance the oxidation number by substituting the electrons. So here we have 6 plus, and then here 14 plus minus 2 is 12 plus. Okay, so to balance it, here need to add 6 E minus, so it will become like this. Okay, so after that, to balance the ion equation, we have to combine the oxidation and the reduction equations together. But however, before doing that, we have to eliminate this E minus by how? By making sure the electrons number are the same. So here is 6 E minus, right? But here initially is actually E minus only. So I times 6 to make sure it is 6 E minus also. So we can make away this. Make away this. It becomes 6 E minus, right? So it deduct and become 0 already. So after that, we put them together. So 6Fe2 plus aqueous plus Cr2O72 minus aqueous plus 14H plus aqueous. Then it will produce 6Fe3 plus aqueous plus 2Cr3 plus aqueous plus 7H2O liquid. Okay, so for the second question, we have to find the concentration of Fe2 plus ions in the solution. Okay, so as we know that concentration equals to mole divided by volume. So from the question, right, it initially given the volume. Volume is 30 ml. So now we lack the info of this mole. In order to find mole, we have to first find the mole for the Cr2O72 minus from the solution of K2Cr2O7. Okay, because it is already stated in the question for its concentration and also the volume. Okay, so we just simply find the number of moles of Cr2O72 minus ion by applying N equals to mV over 1000, and it is like this. M equals 0.1, volume is 50 divided by 1000. Because why we divide by 1000 is because we want to make it into liter. Because it is initially ml, becomes liter. Only then we can divide. And then after the calculation, it will become 5 times 10 to the power negative 3 mole. And then, but we have to find the mole for Fe2 plus ion. Okay, so from this equation, we know that 1 mole of Cr2O72 minus 1 mole is equal to 6 mole of Fe2 plus 6 mole. Okay, so we have to simply comparing them. Okay, so 1 mole of Cr2O72 minus ion is equivalent. This is the symbol of equivalent to 6 mole of Fe2 plus ion. So from here, we find 5 times 10 to the power negative 3 mole Cr2O72 minus ion. So it's equivalent to what? So it's equivalent to this. Okay. This one is fine by deducting 6. By deducting 6, because 1 mole got here and here got 6 mole, so we deduct. So we times 6. And then finally we have to find the molarity or the concentration. So as I have mentioned earlier, to find the concentration, we have to find the mole and the volume of the Fe2 plus. Okay, so 0.03 mole divided by 50 times 10 to the power negative 3 L. We have to know that it is L. It cannot be ml, so we times 10 to the power negative 3, or simply divide by 1000, and finally you will get the answer like this: 1.00 mole L negative 1, or 1.0 small m. Sorry, it's big M. Big M is for molarity, and small m is actually for molarity. Or this is also mole gathering negative 1. Okay, so for the C, zinc reacts with hydrochloric acid to produce zinc 2 chloride and hydrogen gas as follows. This is the equation. So 1503 was dropped in a beaker containing HCl of unknown concentration. After the reaction had ended, 50 grams of unreacted remain. Okay, so it is not actually 150 grams at first is used, but it's 150 grams minus 50 grams. This is actually the gram used in the equation, because there is 50 grams unreacted, so this is the left ones in the beaker. Here is left here. Okay, so to determine the limiting reactant in the first Roman, it is simply the opposite of excess reactant. Okay, so since 50 gram of the unreacted zinc remain in the beaker, so zinc is the excess reactant. Thus, hydrochloric acid is the limiting reactant. We have to know that reactant is actually the left-hand side of the equation. Okay, so next we have to calculate the moles of the hydrochloric acid reacted. Okay, so we can simply by comparing, and then we can find the number of mole for hydrochloric acid. Okay, so as I mentioned earlier, mass of the reacted zinc is 100 gram. So we have to use the reacted zinc to compare. We cannot use the initial mass of the zinc because it still have some left reactant inside the beaker. So after that, I've used the number of mole. I find the number of mole of reacted zinc by dividing with the relative atomic mass of zinc. And after that, I find the answer 1.5291 mole. Please note that you must be in 4 decimal places before the final answer. And then after that, by using this formula, I know that 1 mole of reacted zinc is equals to 2 mole of hydrochloric acid. So 1.5291 mole of reacted zinc is equivalent to this one, 3.0582 mole of hydrochloric acid. Okay, so for the third question, calculate the mole of hydrogen gas produced. Mole of hydrogen gas. Okay, so this one is also the same by just simply comparing. So as we know that hydrochloric acid is the limiting reactant, yeah. So we use this to compare, but not using the excess reacted zinc. So 2 mole of hydrochloric acid is equals to 1 mole of hydrogen gas. So 3.0582 mole of hydrochloric acid is equivalent to 1.5291 mole of hydrogen gas. Okay, so finally, if the experiment was performed at STP, so we have to know that this one is 22.4 dm3 mole negative 1. Okay, so calculate the volume of the hydrogen gas. So initially we actually find the mole, so we can just simply times with this STP to find the volume of the hydrogen gas. Okay, so volume of the hydrogen gas produced is 1.5291 mole times 22.4 liter mole negative 1. So we get the final answer 34.25 L. Please note that it is also 2 decimal places for the final answer. Okay, so that's all for me. Thank you.